Hi, ladies and gentlemen. So today what we're going to be doing is learning about solubility and molarity together. So we're going to add one last step into our problems. When we do this, we're talking about soluble versus insoluble. And if you remember way back when we did our separations methods in our separation lab, we talked about things being soluble as being things that dissolved in water. So if we see something that says soluble, we know it can dissolve in water, which means if it's insoluble, it's going to do the opposite. So it's not going to dissolve in water. All right, but why is that important to us? So if we remember that molarity is the concentration of a solution. So how concentrated or how many moles there are in a solution of this compound, these ions, how many ions there are separated into this solution. Well, if an object or a compound cannot dissolve into water, there can't be a molarity for you to calculate. So there's no molarity you can use. If it can be dissolved in water, then our molarity calculation needs to take place. We can actually do these calculations and create that solution. This is important to us because later on, we're going to see that when things are insoluble, when they create this reaction, we can see that something that's insoluble, it's going to come back out. And so it's going to create something we call a precipitate. But it's also going to be important to us because then we know we can't make that solution. And then that just gives us one less thing to worry about. So we're going to do the same calculations we did yesterday, but we're also going to add one last step. So the first thing we need to do is identify the compound. So we have lithium carbonate. Once we know the compound, we can figure out, based on our solubility chart, if it's going to be soluble or insoluble. Now, this one is the one on Canvas. It looks a little bit different than the one you're going to have on paper. But if we look at lithium, which is right here in the top, in the second column, lithium right here, and we look at carbonate, which is right here, we can see that they correspond when they cross or intersect. It does in fact say it's soluble, right? If it says it's soluble, that means it will dissolve in water, which means the solution can be made, which means now we have to do that calculation to figure out how many grams we would need. So now we go back and we find the molar mass of lithium carbonate, just like always. So we have lithium carbonate, which is Li2CO3, because there's one plus one charge for lithium and a -2 charge for carbonate. And then we have lithium, carbon, and oxygen, lithium being 6.94, carbon being 12.01, and oxygen being 16 for the molar masses. We have 2 lithiums and we have 3 oxygens. And now we can add all those together to get a molar mass of 73.89 grams of lithium carbonate is equal to 1 mole of lithium carbonate. All right, and maybe you want to write down that it was in fact soluble, just so you remember that you checked that. Now it tells us that we're going to find the number of grams. We were given a amount of liquid, a liter, and we're given a molarity. So we can go ahead and use our molarity equation. So molarity equals moles over liters. So we have 1.5, sorry. We have 1.5 molar solution is equal to the number of moles divided by 34.56 liters. If we go ahead and solve for the number of moles by multiplying both sides by 34.56 liters, we're going to get the number of moles is equal to 51.84 moles. Granted, we have to worry about sig figs again, so we have 2 significant figures in molarity and 4 in liters, but we want the lowest number, so we have 52 moles of lithium carbonate. We can go ahead and now use those moles to convert to grams using our railroad tracks. So we know 52 moles of lithium carbonate. And we know that based on our molar mass, for every 1 mole of lithium to carbonate is going to be equal to 73.89 grams of lithium carbonate. Which means when we multiply the top together, we're going to end up with 3,842, 0.28 grams. But again, we have to worry about significant figures from our problem. And since our given was in 2 significant figures, our answer is in 2 significant figures as well. So we want to round to 3,800 grams of lithium carbonate. And now we're done. Let's go ahead and look at one more just to be safe. So if we look at the next one, calculate the volume of the 34.65 grams of zinc hydroxide in a 2.5 molar solution. So let's go ahead and look at zinc hydroxide. And so we need to go back to our solubility table again. Our solubility table, we find zinc and we find hydroxide. So zinc is way over here. Hydroxide is right here. If we intermix these two or find where they correspond, it looks like it says insoluble. And if it says insoluble, we can write insoluble. And now you're done with problem number 2. All right, guys, if you have any questions, let me know.